Hello everyone, welcome back to the channel. In today's video, we are going to explore another core pillar of object-oriented programming called polymorphism. Polymorphism is one of the most powerful and flexible concepts in OOP, and it plays a major role in designing scalable, maintainable, and real-world software systems. Along with encapsulation, abstraction, and inheritance, polymorphism completes the foundation of object-oriented programming. By the end of this lecture, you will clearly understand what polymorphism means, why it is important, how it works, and how it is used in real-world applications. The word polymorphism is derived from two Greek words, poly, meaning many, and morph, meaning forms. In object-oriented programming, polymorphism means one name, many forms. It refers to the ability of a single method, function, or interface to behave differently in different situations. In simple terms, polymorphism allows the same operation to perform different actions depending on the object that is calling it. This concept enables flexibility and makes programs more dynamic and extensible. In real-world software development, systems often need to handle multiple related objects in a uniform way, while still allowing each object to behave differently. Without polymorphism, developers would need to write separate code for each type of object, leading to duplication and complexity. Polymorphism solves this problem by allowing one common interface to represent different underlying behaviors. This reduces code complexity, improves readability, and makes the system easier to extend and maintain. To understand polymorphism better, consider a person. The same person can behave differently in different roles. At school, the person may act as a teacher. At home, the same person acts as a parent. In a shop, the person acts as a customer. The person is the same, but the behavior changes depending on the situation. This is a perfect example of polymorphism. In programming, the same method name can perform different actions depending on the object that invokes it. Polymorphism is closely related to inheritance. It usually works when a child class inherits from a parent class and overrides a method of the parent class. When a parent class reference is used to refer to a child class object, the method of the child class is executed at runtime. This behavior is known as runtime polymorphism and is a powerful feature of object-oriented programming. Without inheritance, achieving polymorphism would be difficult and less effective. Consider an animal class with a method called makeSound. Different animals produce different sounds. A dog may bark, a cat may meow, and a cow may moo. Even though the method name makeSound is the same, the actual behavior differs for each animal. When the program runs, the correct version of the method is called based on the object type. This demonstrates polymorphism in action, where one method name leads to multiple behaviors. Polymorphism is generally divided into two main types: compile-time polymorphism and runtime polymorphism. Both types serve different purposes and are used in different scenarios. Compile-time polymorphism occurs when the method to be executed is determined at compile time. This type of polymorphism is commonly achieved through method overloading. In method overloading, multiple methods have the same name but different parameters. The compiler decides which method to call based on the number or type of arguments passed. Compile-time polymorphism improves code readability and allows developers to use intuitive method names. Runtime polymorphism occurs when the method to be executed is determined at runtime. This is usually achieved through method overriding, where a child class provides its own implementation of a method defined in the parent class. Runtime polymorphism allows a program to decide which method to execute while it is running, making software more dynamic and flexible. This type of polymorphism is heavily used in large applications, and frameworks. Method overriding is a key mechanism that enables runtime polymorphism. When a child class overrides a method of its parent class, it provides a specific implementation suitable for that child class. Even though the method name remains the same, the behavior changes. This allows different objects to respond differently to the same method call, which is the essence of polymorphism. Polymorphism offers several advantages in software development. It improves code flexibility, as new classes can be added with minimal changes to existing code. It enhances code reusability, as common interfaces can be reused across different classes. Polymorphism also simplifies code maintenance, since changes in behavior can be isolated within specific classes. Additionally, it makes programs more scalable, allowing systems to grow and evolve over time. Polymorphism and code extensibility. One of the most important benefits of polymorphism is extensibility. When a program is designed using polymorphic principles, new features can be added easily without modifying existing code. For example, adding a new animal type does not require changing the logic that calls make sound. The new class simply provides its own implementation. This follows the open-closed principle, which states that software entities should be open for extension but closed for modification. Polymorphism in real-world applications. Polymorphism is widely used in real-world software systems. In graphical user interfaces, different buttons may respond differently to the same click event. In payment systems, different payment methods may process payments in different ways. In gaming, different characters may respond differently to the same action command. Polymorphism allows developers to handle all these cases using a common interface while supporting different behaviors. Without polymorphism, developers often use long conditional statements to handle different behaviors. This approach makes code complex and difficult to maintain. Polymorphism eliminates the need for such conditions by allowing objects to decide their own behavior. This results in cleaner, more readable, and more maintainable code. Common mistakes in using polymorphism. One common mistake is misunderstanding polymorphism as only method overloading. While overloading is a form of polymorphism, true power lies in runtime polymorphism through method overriding. Another mistake is using polymorphism where it is not needed, leading to unnecessary complexity. Understanding the correct use cases is essential for effective object-oriented design. Polymorphism and object-oriented design. Polymorphism is a key component of object-oriented design patterns and principles. It helps in building loosely coupled systems where classes depend on abstractions rather than concrete implementations. This leads to flexible and maintainable software architectures. Polymorphism is heavily used in design patterns such as strategy, factory, and observer. In modern software development, polymorphism is everywhere. Frameworks, libraries, and APIs rely heavily on polymorphic behavior to provide extensibility and flexibility. Without polymorphism, building large and complex systems would be extremely difficult. Understanding polymorphism is therefore essential for any programmer aiming to work on real-world projects. To conclude, polymorphism is a fundamental concept in object-oriented programming that allows one method or interface to represent many forms. It enables flexibility, reduces complexity, and improves scalability in software systems. By allowing objects to behave differently while sharing a common interface, polymorphism makes programs more elegant, maintainable, and extensible. Mastering polymorphism is a crucial step in mastering object-oriented programming as a whole. Thank you for watching this detailed lecture on polymorphism in object-oriented programming. If you found this explanation helpful, please like the video, subscribe to the channel, and share it with others. In the next lecture, we will explore abstraction with the same easy, paragraph-based explanation style. Until then, keep learning, keep coding, and happy programming. 火箭